The universe is vast. It's filled with billions upon billions of galaxies, each teeming with stars and planets. But where did it all come from? How did something as immense and complex as our universe come to be? The answer, my friends, lies in an event so monumental, so fundamental, it defies our everyday understanding of time and space, the Big Bang.
Picture, if you will, a single tiny speck. Smaller than a grain of sand, smaller even than an atom. This speck, this singularity, held within it the entirety of our universe. All the matter, all the energy, all of space and time itself, squeezed into an infinitely dense point. It's hard to wrap our minds around such a concept. We are used to vast distances, expansive spaces. Yet before the Big Bang, there was no space as we understand it. No up, down, left, or right. Time itself was frozen, meaningless in the face of such infinite density. Think of a balloon, completely deflated. The balloon's surface represents all of space, and the air inside represents the universe's matter and energy. In its deflated state, the balloon's surface has no area, and the air inside is compressed to a single point. This is our pre-Big Bang singularity. While this analogy has its limitations, it helps us visualize the state of the universe before the Big Bang, a state of unimaginable density and potential on the verge of something extraordinary.
Then, in an instant, everything changed. The universe, once a singular point of unimaginable density and heat, began to undergo a transformation that would set the stage for everything we know today. The singularity, that point of infinite density, began to expand. This expansion wasn't a simple explosion. It was a profound event that marked the birth of our universe. This wasn't just an explosion of matter into existing space. It was the expansion of space itself. Space and time, intertwined in the fabric of the cosmos, began to stretch and grow. Imagine our deflated balloon suddenly inflating, its surface stretching outwards in all directions. This analogy helps us grasp the concept of space itself expanding, carrying galaxies and stars with it. This was the Big Bang, a moment of creation that defies simple explanation, yet is the cornerstone of modern cosmology. Not a deafening roar, but a silent, rapid stretching of space-time. The universe expanded faster than the speed of light, a phenomenon known as cosmic inflation. In fractions of a second, the universe went from infinitesimally small to astronomically large. This rapid expansion set the stage for the formation of the cosmos as we know it. As it expanded, it cooled, and the energy that was once confined to the singularity began to transform. This cooling allowed for the formation of subatomic particles and eventually atoms. This transformation is key to the formation of everything we see around us. The cooling universe allowed for the creation of hydrogen and helium, the building blocks of stars and galaxies. Einstein's famous equation, E=mc², tells us that energy and matter are two sides of the same coin. This principle was at play in the early universe, where energy condensed into matter. In the extreme heat of the early universe, energy condensed into matter, giving birth to the first fundamental particles. Quarks and electrons emerged, eventually forming protons and neutrons. The Big Bang wasn't just an event, it was the beginning of everything we know and everything we are. It marked the start of a cosmic journey that continues to this day. It set the stage for the formation of stars, galaxies, planets, and ultimately, life itself. Over billions of years, gravity pulled matter together, forming the complex structures we observe in the universe today. The universe has been evolving ever since, with galaxies merging, stars being born and dying, and planets forming around new stars. This dynamic process continues to shape the cosmos. Our understanding of the universe has grown immensely, yet there is still so much to learn. Each discovery brings us closer to comprehending the vast, intricate tapestry of existence. As we look to the future, the exploration of the universe promises to reveal even more wonders. From the smallest particles to the largest galaxies, the story of the cosmos is far from complete. Human curiosity drives us to explore, to understand, and to marvel at the universe. It is this curiosity that will continue to propel us forward, uncovering the mysteries of the cosmos.
Dissection 4, the first elements. Building blocks of existence. In the first few minutes after the Big Bang, the universe was a chaotic soup of fundamental particles, quarks, leptons, bosons, interacting at incredible speeds. These particles were the most basic components of matter, and their interactions were governed by the fundamental forces of nature. Temperatures were so high that the formation of atoms, the building blocks of matter as we know it, was impossible. The intense heat and energy kept these particles in a state of constant motion, preventing them from coming together to form more complex structures. However, as the universe continued to expand and cool, a remarkable transformation began to occur. The rapid expansion caused the temperature to drop, allowing particles to slow down and interact in new ways. Quarks, those fundamental particles that make up protons and neutrons, started to combine. This process, known as nucleosynthesis, was the first step in the creation of matter as we know it. Like dancers pairing up at a cosmic ball, quarks came together in groups of 3, forming the first protons and neutrons. These combinations were not random. They followed specific rules dictated by the strong nuclear force. These protons and neutrons, in turn, began to attract each other through the strong nuclear force, one of the 4 fundamental forces of nature. This force is incredibly powerful, but it acts only over very short distances, binding protons and neutrons together to form atomic nuclei. This attraction led to the formation of the first atomic nuclei, the hearts of atoms. These nuclei were the seeds from which all matter in the universe would eventually grow. The universe was now a few minutes old, and the stage was set for the creation of the first elements. The conditions were just right for these nuclei to capture electrons and form neutral atoms. The simplest and most abundant element in the universe, hydrogen, was the first to form. Hydrogen atoms consist of just 1 proton and 1 electron, making them the simplest and most fundamental building blocks of matter. As the universe cooled further, some of these hydrogen nuclei captured neutrons, forming helium, the second lightest element. This process, known as helium nucleosynthesis, was crucial for the development of the universe. These 2 elements, forged in the crucible of the Big Bang, would go on to play pivotal roles in the evolution of the universe. Hydrogen and helium are the most abundant elements in the universe, and they serve as the building blocks for all other elements. The formation of these elements marked the beginning of a new era in the universe's history, setting the stage for the formation of stars, galaxies, and eventually, life itself. Over millions of years, hydrogen and helium began to clump together under the force of gravity, forming the first stars. These stars were the factories where heavier elements would be forged through the process of nuclear fusion. Inside the cores of these stars, hydrogen atoms fused together to form helium, releasing enormous amounts of energy in the process. This energy caused the stars to shine and provided the heat and pressure needed to create even heavier elements. When these stars reached the end of their life cycles, they exploded in massive supernovae, scattering the elements they had created into space. These elements would go on to form new stars, planets, and eventually, the building blocks of life. The elements scattered by supernova combined to form new stars and planets. On at least one of these planets, Earth, the conditions were just right for life to emerge. The building blocks of existence, created in the first moments after the Big Bang, had come together to create the complex and diverse universe we see today.
Section 5. From Chaos to Cosmos, the Formation of Galaxies. The story of galaxies is one of transformation, from a chaotic beginning to the structured beauty we see today. The early universe, although teeming with the newly formed hydrogen and helium, was far from the structured cosmos we observe today. It was a vast expanse filled with potential, but lacking the intricate structures that would later emerge. It was a place of intense heat, radiation, and a chaotic dance of particles and energy. The universe was a seething cauldron where the fundamental forces of nature were in a constant state of flux. However, within this chaotic environment, the seeds of order were already being sown. These seeds were the tiny fluctuations in density, the subtle imbalances that would eventually lead to the formation of galaxies. Gravity, that ever-present force that draws matter together, began to exert its influence on the primordial soup. It acted as a cosmic sculptor, slowly but surely pulling matter into clumps. Tiny fluctuations in the density of the early universe, remnants of the Big Bang itself, acted as gravitational seeds. These minuscule variations were the first hints of structure in an otherwise uniform expanse. These regions of slightly higher density began to pull in surrounding matter, like cosmic dust bunnies gathering under a bed. Over time, these regions grew more pronounced, becoming the building blocks of galaxies. Over millions of years, these clumps of matter grew larger and denser, eventually collapsing under their own gravity. This process was slow and gradual, but inexorable. leading to the formation of the first galactic structures. As they collapsed, they spun, their rotation accelerating as they contracted. This spinning motion was crucial, as it helped to shape the emerging galaxies into the forms we recognize today. These swirling, collapsing clouds of gas and dust were the progenitors of galaxies, the vast island universes that populate our cosmos. Each galaxy began as a chaotic cloud, but over time, gravity and rotation worked together to bring order to the chaos. Within these nascent galaxies, gravity continued to sculpt and shape the distribution of matter. It was a delicate balance, with gravity pulling matter inward while the rotation of the galaxy provided a counteracting force. The stage was set for the next act in the universe's grand story, the birth of stars. These stars would light up the galaxies, bringing warmth and energy to the cold, dark expanse of space. The formation of galaxies was just the beginning, a prelude to the even more complex and wondrous processes that would follow. Within the galaxies, regions of gas and dust began to collapse under their own gravity, forming dense cores that would eventually ignite as stars. These star-forming regions were the nurseries of the universe, where new stars were born and began their life cycles. Over billions of years, galaxies evolved into a variety of shapes and sizes. Some became majestic spirals, with their graceful arms winding around a central bulge. Others formed into elliptical shapes, more uniform and less structured. Still, others remained irregular, their shapes dictated by the chaotic interactions with neighboring galaxies. Galaxies did not evolve in isolation. They interacted with one another, sometimes merging to form larger galaxies. These cosmic collisions were dramatic events, reshaping the galaxy and triggering bursts of star formation. Today, we look out into the universe and see countless galaxies, each a testament to the processes that began billions of years ago. The formation of galaxies is a story of transformation, from chaos to order, from simplicity to complexity. It's a story that continues to unfold as galaxies evolve and change over time. Our own Milky Way galaxy is just one of these countless galaxies, a vast island of stars, gas, and dust. It is our cosmic home, a place of beauty and wonder shaped by the same forces that have shaped all galaxies. The future of galaxies is one of continued evolution. They will continue to interact, merge, and change, driven by the same fundamental forces that have shaped them from the beginning. The story of galaxies is far from over, and it is a story that we are privileged to witness.